Okay, so we are going to now be able to do trig equations. So by now you should be able to know enough information where you're going to solve an equation. It's pretty much the same way that you would solve a regular equation when we did before, whether it's quadratic, whether it was linear, whether it was any type of function, we were able to solve it. So trig equations are pretty much the same thing, but you have to remember the trig rules, a lot of it. So the process is still the same. So here's a couple of things that you definitely need to know. So one of the things that you need to know is that they're giving you here where the angle should be. Like, because trig functions, in the unit circle, they could go all around and around and around and find many, many answers to it. So this question is saying, what angle does sine give you the square root of 3 over 2? Well, I could keep going on, going counterclockwise and then clockwise infinitely in both directions, and it's going to be a lot of angles are going to give me the square root of 3 over 2. But we've put the restriction so that we could say from 0 to 2 pi over 2. If there were no restrictions, then we would have to come up with the formula. So let's start off with where there are restrictions. The restrictions also tell you in what angle your answer should be, in what format, whether it should be in degrees or in radians. So in this case here, the angle should be from 0 to 2 pi, so they're giving you in radians, so therefore your answer should be in radians as well. So looking at this is what angle is going to give you the square root of 3 over 2? Well, I know that the square root of 3 over 2 is one of the angles that we could do really easily on the unit circle. And so the square root of 3 over 2 means that there's going to be 3 fingers below the bended finger. And so that's going to give me 60 degrees, which in radians, because that's what I want to be in radians, that is going to be pi over 3. So I know that the angle that I'm looking for is positive trig ratio. So where is sine going to be positive? Well, sine's going to be positive in quadrants 1 and in quadrants 2 because we do the all students take CAT. And so I know that it's going to be in quadrants 2. So if this here has a reference angle of 60 degrees, this one here is also going to have a reference angle of 60 degrees. And so then I know, and you could do it by counting radians as well. So you could do like 0, 1, 2, 3, 4. We know that that's going to be 4 pi over 6, which reduces to 2 pi over 3. So the angle that's falling in, and it's all angles between 0 and 2 pi, I know that this trig ratio here for this 60 degrees and this 60 degrees, they're both negative, so that can't be it. So all the angles are going to be, theta can only be pi over 3, and it could be 2 pi over 3, and that will make that trig ratio the square root of 3 over 2. So whether I do the sine of pi over 3 or the sine of 2 pi over 3, I'm still going to get the square root of 3 over 2. And that's how you solve it. Okay, so now let's do this one here. It says the cosine of theta is equal to 0, but it's going to be between 0 and 4 pi. That means we go once around and again around. So we know that this here is 0, and then once around is going to be 2 pi, and then I go around again and it's going to be 4 pi. So that means that I am going to have to go around twice and it's going to be more than 2 answers. So when does cosine equal to 0? So cosine is the x-axis. So cosine here is going to be 1, and this one here is going to be 1. So here is where it's going to be 0 because there is no x-axis along the y-axis, right? There is no distance on either side. So we know that cosine at, and again, radians, so we have to do it radians. Once going around is going to be, and I could count it, 0, 1 pi over 2, 2, 3 pi over 2. And then I could say that theta is going to be at pi over 2. At 3 pi over 2, that's where it's going to be. And then I don't stop at 2 pi, I have to go again. So this is going to be 3, 4, this is 5, 6, and 7. So that's going to be at 5 pi over 2 and at 7 pi over 2. If it was longer or if it was in a different direction, we'd have different answers. But in this case, it's from 0 to 4 pi. So we're just going to start at the center and then go around twice. And that is going to be your answers. So in number 4, we're doing the cosecant of theta is equal to 2. So cosecant, if you remember, is the reciprocal of sine. So in this case here, I know that it's going to be sine of theta, and it's the reciprocal, so it's 1/2. So when is sine of theta going to be 1/2? It's the same thing as saying when is the cosecant of theta going to be 2. So I know sine is going to be 1/2. That is going to be when it's one finger below the bended finger, and so that's at right here at 30 degrees, which is pi over 6. Again, looking radians, so I have to work with radians. And so I know that it's going to be there, but it's between 0 and 4 pi. So that means I'm going to have to go around twice. But first of all, cosecant and sine follow the same way. So that means that it's going to be right here. And I'm going to do some counting on there. So it's going to be 0, 1, pi over 6, 2, 3, 4, 5. So I know it's going to be at 5 pi over 6. But that's only going to be once because I know that it can't be here and it cannot be there because this one has a 30 reference. This is 30, this is 30, that is 30. But I know it can't be here because the cosecant is going to be negative here and negative here, and we want it to be a positive 2. But it's to 4 pi. So that's not just going to be, so theta is not just going to be pi over 6. It's also going to be 5 pi over 6. And then I keep going around. So I'm just going to keep counting because that's going to work for me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then this is 12. So that 12 is the 2 pi, but I have to do it again. So then I'm going to go again. I'm going to do that in green. So that's 12, 13, 14, 15, 16, 17. So the two angles that are going past it is going to be 13 pi over 6 and 17 pi over 6. And those are the angles for number 4 for cosecant of theta. Okay, so number 6 here, this is, and the other ones, we didn't really do any kind of like, let's say, algebra pretty much on there. That was just full trig here. Now this one here is going to be a little bit more. It's more algebra on there because notice how it's not just tangent of theta, it's tangent of 2 theta. So we have things in there. And then this one here is saying negative 2 pi to 2 pi. So that means we're going to go once counterclockwise and once clockwise. So we're going to have answers going this way. So those are going to be positive, and answers going this way, which those are going to be negative. So first, before we start deciding what angles, and again, radians, we have to keep it in radians, but before we start doing that, we're going to take the inverses, right? Because we need to get the theta by itself. So we're going to do 2 theta is going to be tangent inverse of -1. The tangent inverse of -1, we know the -1 is a trig ratio. It's the inverse, so it's going to have a restriction. So where is it actually going to put it? And the answer that the restriction is going to put it here, again, -1 is a 45-degree angle, so it's going to be at -4 pi. Because tangent is negative, it's going to fall in the negative quadrant. Remember, the inverses for tangent are always going to fall either here or here. Those are the restrictions for the inverse. So I know it's going to fall here at -pi/4 because it's a 1. Sine and cosine have to be equivalent, and they're equivalent at, so that they could cancel out to 1 at pi/4. Okay, so now I have that. So I know it's going to be here, but I am not solving for the inverse. I'm just using this to give me the answer to answer my original question. The original question has no restrictions because there is no inverse here. I just used the inverse to help me solve the original problem. So I'm just using that. So the answer that it gives me is -pi/4 here, but tangent is equivalent to -1. It's going to be negative in quadrants 2 and in quadrants 4. So down here, oops, let me get rid of that. Um, so that one there, this one's going to be negative there as well. So this one here, if I look at it and if I count it, because these are all pi's over 4s, that's going to happen at 0. This is 1, 2, 3 on there. So it's going to be at 3 pi over 4. So, and then I keep going on there because it's going to be once counterclockwise. So I'm going to keep going, and it's still this angle right there. So it's 3, 4, 5, 6, and this one's going to be 7. And then, of course, that's 8. So here, once going counterclockwise is going to be 2 theta is going to give me 3 pi over 4 and 7 pi over 4. But now I need to go counterclockwise. And that counterclockwise is actually this negative pi over 4 that's going to be there. And so that's going to be, if I count backwards, this is -1, -2, -3, -4, -5, -6. And I don't really need to keep going further because the one that I'm looking for is this one here, because that's where the tangent, they're going to share the same trig ratios, which is they're sharing this trig ratio there. So the other angle is going to be -5 pi over 4. So it's going to be negative pi over 4 and then -5 pi over 4. Now, if it was just tangent of that, we would stop there, but we're not done because we're solving for theta here. We want to find the unknowns. So in order to do that is, this is 2 times theta. So that means that the angles, if it's twice the angle, that means that these angles are twice the value. So I need to get rid of that twice. And so I'm going to divide everything by 2 or multiply by 1/2. Since these sides are fractions, it's much easier than to divide by 2 is to multiply by the reciprocal. So what I'm going to do is multiply this by 1/2. And so this is over 1, that's going to cancel. I'm going to multiply this by 1/2, multiply that by 1/2, multiply that by 1/2, multiply that by 1/2, because that means that all the angles, which are those 4 angles, are actually half the angles because it's twice that angle. And so we end up with our final answer to be 3 pi over 8, 7 pi over, so that's a 2, not a 4, 8, negative pi over 8 and negative 10 pi over 8, which this one does reduce, and it'll reduce. You could leave it like that, but you could also reduce it to 5 pi over 4. That does not, because I don't know what I was thinking there. So it does not reduce. It's 5 pi over 8. I don't know what I was thinking there. I multiplied the 5. Anyway, so those are your answers there. So again, you need to solve for theta. And so we need to move it over. And since this here, now theta is equal to this, twice these angles or twice theta is what I would multiply those by 2 and it'd get back to that part. So we want theta, not twice the theta. So that's the answers for that. Okay, so here's the question. Notice how in this problem, tangent theta is equal to 0 and all real numbers. Notice how we are not giving a restriction. And so we want all real numbers. Now we're going to keep that in terms of radians, okay, because it's much easier to do them in terms of radians than in degrees. Well, we just want to get used to radians anyways. So here we want to know when tangent of theta is equal to 0. So that means that when I'm looking at this, tangent is going to be, we know that tangent is sine of theta over cosine of theta. So we want, we don't care what cosine of theta is, that's just going to be a number because it's equal to 0. So there has to be a number under the denominator. Sine has to be 0. So when is sine going to be 0? And that's going to be right here. So sine is the y values, and there is no y values here, and there is no y values there. So sine is 0 at 0 and at pi, or 0 at 180. So we want it for all real numbers. So the angles that is going to be, that means I'm going to be able to go infinitely many times this way and infinitely many times counterclockwise and clockwise. And it's just going to give me, I can't write all those numbers. You'll be up and you'll be old by the time you write them all. So we do not want that. So we want to know when theta is going to be, what angle of theta is going to give us 0. And so if we could find a pattern and write a pattern. So depending on which way that I go, if I start, I have a lot of numbers before this, but if I go this way, I could start at negative pi, right? And negative pi, if I'm going this way, it's negative pi, and then 0, and then 1 pi, and then going around 2 pi, because I could keep going around. So if I start here, it's a negative, then 0, then pi, then 2 pi, then 3 pi, then 4 pi, and so on and so forth. And so then I keep going on and adding the pies. So what do you notice for that? And it's going to keep going on and on, either whether we go one way or the other, and it doesn't really matter. Theta, in this case here, what's changing? If you notice, it's the -1, the 0, the 2. The coefficient of pi is actually changing. So we say maybe n for the coefficient, where n is going to be an integer, and we say n and then pi. So for any integer n, if we put that in there, we are going to get the angles for theta. And so that's how you would write a formula on there. Okay, very good.